और कौन से क्वेश्चन बन जाएंगे, फर्स्ट सेकंड थर्ड फोर्थ, इसमें एक एक करके चेक करते जाओ जिसमें
The
तो बोला।
ninth first part, can we solve it?
Yes, 9 first part we can solve. Let's check this problem, how we can solve this. Again, the same type of property will be used. Integration e raised to power 6 log x minus e raised to power 5 log x divided by e raised to power 4 log x minus e raised to power 3 log x dx. So the first step will be e raised to power. Here it will be log x to the power 6 minus e raised to power log x raised to power 5 divided by e raised to power log. Is it clear? चेक करते जाओ, जहां डाउट होगा पूछ लेना.
Yes, sir.
What will be the next step after this?
So can we take common and then cancel it?
Yes, definitely. We will take x raised to power 5 common from numerator. We will get x minus 1. Whereas from denominator, we will take x cube common and we will get x minus 1. Now this x minus 1 gets cancelled. Further, this term also get cancelled and we will get only x square in numerator. Now further integrate and you will get your answer.
Yes, sir.
Hmm. Any other question from this? You can also check the second part of ninth, in which hint is given to you.
Sir, here also we can divide it, no?
Yes, we can divide here also, but that long division process of polynomial takes time, and it is also possible that we make some mistake while dividing. Okay. Okay. Any other question from this exercise 7.2? Well, the usually asked question or important questions are like second part of question 8, which we had already solved. Second part of question 5. Also the second part of question 6. Also that second part of question 2. I think these are some important questions which can be asked for 1 or 2 marks. Okay.
Sir, second question, second part, can we do that once?
Second question, second part. Okay. Second question, second part is integration 2a upon root x minus b upon x square plus 3c square cube root of x square. Okay. So first what we will do, we will take 2a outside this integral. Here x raised to power minus half, we can write this term as x raised to power minus half dx. Minus b we can take outside the integral, x raised to power minus 2 dx plus 3c square as it is, integral x raised to power 2 by 3 dx. We can write it like this. Kindly check and tell me whether you have understood or not this part. Well, this
Yes, sir.
complete term is there, dx is there, so I have separated the terms. Also, this root x I have written as 1 upon root x is there, so written like this. This x, this term can be written like this. This part can be written like this. Okay. Okay. Also, one more thing you must have to keep in your mind, that we can do this only in case when the terms are, when the functions are not in multiplication. They are separated by either plus or minus. Then only we can separate the integrals. Okay. Okay.
Yes, sir.
So can we move to the next exercise?
Sir,
हाँ
uh,
बोलो.
second part of question 9th.
Second part of question 9. Actually, hint is already given in that. Check the hint, Naina. First, what is written? We can write x to the power 6 as a square whole cube. Also, we can write 1 as 1 cube. And further, we can apply the identity given just below to the hint a cube plus b cube. So it is a plus b under bracket a square minus ab plus b square.
Yes,
So we
sir.
will get two factors. Is it clear?
Yes, sir.
हो जाएगा ना या इसको एक्सप्लेन करूं बोर्ड में?
हो जाएगा.
ओके. नेक्स्ट में मूव करें. नेक्स्ट सब्स्टिट्यूशन. ये काफी ट्रिकी है ना ये वाला एक्सरसाइज. इसमें ना ज्यादा प्रॉब्लम गई थी तुम लोगों को, मुझे याद है. तो इस यहां से ज्यादा प्रैक्टिस की जरूरत पड़ेगी.
So can we solve from examples?
यस, टेल मी विच एग्जांपल यू.
So like example number 4, second part.
Example 4, second part. Yes. Uh, Actually, before starting with that example, I think we should start solving with some simple problems. Uh, uh, First, a few questions, then we will move to that type of solutions. Okay. So, first problem will be based on this example 2, first part. Okay. So here I is equals to integral ax plus b whole raised to power n dx. So for such questions, what we will substitute? We will substitute ax plus b as another variable t. Further, we also need to substitute dx in terms of dt. So we will differentiate this term. Here derivative of x will be a. Here it will be dt by dx. And further we will get the value of dx, that will be dt upon a. So here this complete term will be replaced with t. So t raised to power n. Dx will be replaced with dt by a. Now we will take 1 upon a outside the integral. Integration of t raised to power n will be t raised to power n plus 1 upon n plus 1. Now put the value of t. So ax plus b whole raised to power n plus 1 divided by a times of n plus 1. Is it clear, both of you, this problem? Okay. Now which
Wait,
question? हाँ बोलो नैना.
how a equals to dt by dx?
uh, how when we differentiate this equation
Okay, so we are
with respect
differentiating
to
here.
so derivative, yes, after substituting, the next step is differentiation with respect to x. So the derivative of ax will be a, derivative of b will be 0, derivative of t will be dt by dx. Is it clear, Naina?
Yes, sir.
Okay. Now which question, Chevy? Question number? Example
For
number?
example 4, second.
Example 4, second part. Okay. Actually, for these type of question, there are certain rules which we can follow for like example 4, second part. Okay. It is integration I is equals to 3x plus 1 root over 2x minus 1 dx. Okay. Now, when we start substituting this, we must or we have two ways to solve this question. Actually, a simpler way will be like this. We can separate the two terms 3x root over 2x minus 1 when we open this bracket plus root over 2x minus 1 dx, like this. This part is clear to both of you.
Yes, sir.
Now the first uh, part will be integration x root over 2x minus 1 dx plus integration root 2x minus 1 dx. Is it clear? Okay. Now what we will do here, we will substitute 2x minus 1 as t. So this part, actually this 2x minus 1 will be replaced with t. Now we will differentiate. So derivative of 2x will be 2. Derivative of 1 is 0. Here it will be dt by dx. So we will get dx is equals to dt upon 2. Is it clear?
Sir, why we are not substituting root 2x minus 1?
No, actually, uh, derivative of root over 2x minus 1 will give you a complex function. Like it will not be a simple function. Its derivative will be 1 upon 2 root 2x minus 1 into something else. So we will substitute that function as t, whose derivative we can easily determine. Okay.
Yes, sir.
Okay, so that's why we have selected this term as t. Okay, now this complete expression will be like 3 integration. Leave this part, just focus on this part, second part, integration. So this root over this term will be root t. Here the this dx will be replaced with dt upon 2. Okay, is it clear?
Yes, sir.
Okay, now for this part again we will do the same thing. This root over t, we can write this complete term as root over t. Here dx can also be written as dt by 2. Now this x creates a problem. So we will replace the value of x also in terms of
So we'll
t.
be writing t minus 1 upon 2.
Correct. Because everything is in terms of t. So we need to find the value of x also in terms of t. So x will be t plus 1 upon 2. Because when we shift minus 1 here, it will be plus 1 upon 2. Clear? So this x will be replaced with t plus 1 upon 2. Is it clear? है ना समझ
Yes,
में आया?
sir.
Hmm. Okay. Now from this part, this 2 and this 2 will become 4. Now we can take 4 outside the integral. So it will be 3 by 4 integration. This t plus 1 remains as it is. Here we can write it like this dt plus, also from here we can take 1 upon 2 outside. Here it will be t raised to power half dt. Is it clear? Now
Yes, sir.
we will multiply this t raised to power half here. We cannot directly integrate here because here the two multiplication of two function is there. So first we have to separate or we have to multiply. So this term will be t raised to power 3 by 2. Why 3 by 2? Because power of t will be added. So 1 plus half you will get 3 by 2. Plus the next term will be t raised to power half and dt is there. Here plus 1 by 2, integration of this part will be 3 raised to power t raised to power 3 by 2 upon 3 by 2 plus c. Always we have to write plus c for indefinite integral. Okay, now integration of this part is still pending, so just apply the integration. T raised to power 5 by 2 upon 5 by 2 plus t raised to power 3 by 2 upon 3 by 2, like this. Plus this 2 and this 2 gets cancelled out and you will get t raised to power 3 by 2 upon 3 plus c. Further you can solve the terms and you will find the proper value or proper answer. Okay, like 3 by 4 into 2 by 5 t raised to power 5 by 2 plus 2 by 3 t raised to power 3 by 2 plus t raised to power 3 by 2 upon 3 plus c. And further we can add these two terms. They are having same denominator and also t raised to power 3 by 2 is there. So it will become 3 into t raised to power 3 by 2 upon 3. This 3 and this 3 gets cancelled and you will get t raised to power 3 by 2 here. Also here we can simplify this term. 2 ones are 2 twos are 4, 2 fives are 10. So we can write 3 upon 10 into this. Oh, sorry. 3 upon 10 into this t raised to power 5 by 2 plus this term is there. So 3 by 10 into t raised to power 5 by 2 plus this term. Now just put the value of t whichever we have considered and you will get the final that derivative integral. Okay. So Naina Shavi, is it clear?
Yes, sir.
Hmm. Now check the exercise 7.3 and tell me which questions you want me to do in here.
Sir, we usually divide when the numerator has a higher degree.
Yes, actually, when the degree of numerator is more than the denominator, then we will apply long division. Like in second part of question 7 from exercise 7.3, page number 380. Okay, second part of question 7. Here also we will apply division of polynomial, or we can also factorize the numerator, and that thing can also be done. Okay, so any question, any one question from this exercise 7.3? नैना, बताओ किसी क्वेश्चन में डाउट है इसमें तो, या ऐसा लग रहा है
Question
कि
8, first part.
क्वेश्चन 8 फर्स्ट पार्ट, जस्ट ट्राई टू रैशनलाइज द डिनोमिनेटर, राइट द क्वेश्चन एंड वी कैन स्टार्ट सॉल्विंग.
So question number 1, second part.
Question 1 second part, 4 e raised to power 3x.
Yes, sir.
Okay,
So what is the integral of e to the power x?
it is same e raised to power x only.
So if it is 2e to the power x.
Just wait, let me tell you how we can solve this. Dx is there. What we will do, we will separate the terms, 4 e raised to power 3x dx plus integration 1 dx. This will be the first step. Now integration of this part will be x. Here 4 we can take outside. Now we will replace this 3x with t. Okay, so 3x will be replaced with t. Now we have to replace dx also in terms of dt. For that we will differentiate this term. So 3 is equals to dt by dx, and from here you will get dx is equals to dt upon 3. Is it clear, Chevy?
Yes, sir.
Okay, so we will write like this. This will become e raised to power t. This will become dt upon 3. Now we can take 4 by 3 outside. Now the integration of e raised to power t with respect to dt will be same, e raised to power t only, plus x plus c. Now put the value of t again and you will get your answer. Okay. Now start.
Here,
हाँ बोलो नैना.
here our ma'am told that we can apply chain rule. Like usually we used to multiply using chain rule in differentiation, but here we have to in the integration we can divide it.
Yes, yes, yes. You are
So
correct.
here, so here without substitution also we can find integration.
Exactly, we can do, because actually that process is derived from substitution only, and this is the core fundamental of that concept. That's why I have explained this thing. But one thing you have to you must have to remember, that if you have a function like this e raised to power x square plus 1, and when you want to integrate this, then in that case chain rule for integration will be failed. Clear? Then you cannot apply that chain rule. It
Yes,
is only applicable when you have a linear function of x in e raised to power x or in any other function as composite form.
So if this e to the power 3x was e to the power 3x square,
Yes.
then how we would have solved it?
Then we could not solve that question. In that case, we must have some other function with that also. Like for an example, if let's take this example only. If we have this function given to us, then we cannot integrate this function in a easier way. Into x must be given to us, so that only we can integrate by using pen and paper. Now how we can use in how we can integrate if x is there? Then we will apply substitution. We will substitute this term as t. We will substitute x square plus 1 is equal to t. Now we differentiate. We will get 2x is equals to dt by dx. Now we will multiply. So x dx is equals to dt by 2. Now we can replace this x dx with dt by 2. Okay. Integration e raised to power. This complete term can be replaced with t. And now it will be 1 upon 2 e raised to power t dt, and we can integrate further. Okay. So only when the power is a linear combination of x, then only we can apply that chain rule of integral. If it is not a linear function of x, like quadratic or cubic function is there, then its derivative must be there, then only we can integrate by substitution. Okay.
Yes, sir.
Hmm. So yes, Naina, your doubt was from that first part of question 8. So here I is equals to integral 1 upon root x plus 1 plus root x plus 2. So for such questions in which you have a square root function, square root function either in addition form or in subtraction form, then you have to rationalize first. So here also we will rationalize the denominator. So it will be like this. Okay, the rationalizing function will be like this. Further, when we apply this, the numerator will be root x plus 1 minus root x plus 2, and the denominator, in denominator we will apply the identity a square minus b square. So the square of first term will be x plus 1 only, the square of second term will be x plus 2 only. Is it clear?
Yes,
Fur-
sir.
Further, when we simplify, we will get minus 1 in denominator, and when this minus 1 is multiplied with numerator, the sign of each term will be changed, and here you will get like this. Okay, is it clear? Now further, how we can integrate? Again, we can substitute, or here the function is linear function, so we can apply that chain rule about which Nana was talking. So how we can apply chain rule here? Here root x, we will consider it as root x. So its power will be x plus 2 raised to power will be 3 by 2 divided by 3 by 2. And now the derivative of derivative of this part will be in denominator. So its derivative is 1, so we can ignore that. And also here also x plus 1 raised to power 3 by 2 divided by 3 by 2, like this. Is it clear?
Yes, sir.
Hmm. Okay. Any other question you want me
So
to solve?
here, question number 7, first part. What we
Yes.
have to do?
Question number 7, first part. Actually, I think yes, the complete denominator will be replaced with another variable t. Look, uh, let me tell you a few things regarding questions based on that particular situation. Here, the situation is x cube upon 2x plus 1. Now, some fundamental we already know that if we have like function like x upon y plus z plus p, so we cannot separate this function. It will be as it is. But if we have y plus z plus p divided by x, then we can write it like this: y upon x plus z upon x plus p upon x. Is it clear? Okay.
Yes, sir.
So it is better to have a single term in denominator so that we can separate the terms and further we can integrate. So for such type of expression in which we have more than one term in denominator, we usually substitute that term with a single variable t. Okay, like here, we will replace 2x plus 1 with t. Now differentiate this, you will get 2 is equals to dt by dx. Now the value of dx will be dt upon 2. Okay. From here, what we can write? We can write integration. This dx will be replaced with dt by 2. Here the denominator will be replaced with t. Now, what about this x cube? So we need to know the value of x. So the value of x can be determined from here. So how we can determine the value of x? So 2x will be equals to t minus 1 and x will be equals to t minus 1 upon 2. Okay. but we need to find value of x cube. So x cube will be t minus 1 whole cube divided by 2 cube, that is 8. So what we can write instead of x cube, we can write t minus 1 whole cube, and divided by 8 we can write here. Okay. So further this 8 and this 2 gets multiplied, and we will take 1 upon 16 outside the integral. In denominator we have t. Now we will apply a minus b whole cube here. So it will be a cube minus b cube minus 3a square b plus 3ab square, like this dt. And further we will separate the terms like this. Nana, is it clear?
Yes, sir.
Okay. Any other question from this? I think both of you try a few questions. Let me give you some question from this exercise. Okay. Try to solve that question number 6 first part. Question number 6 first part in the same way which I have solved this one. So what you have to substitute t in that question?
X plus 1.
Yes.
Sir, done.
Done. Okay. And check the second part of ninth question. Are you able to solve that one also? नैना कुछ प्रॉब्लम सिक्स्थ फर्स्ट पार्ट में?
Almost done.
Okay. And what about the second part of question 9? Just tell me if both of you are able to solve that question, then we can move to the next topic.
Here also we have to substitute 3x minus 2 equals to t.
Exactly. So it will become root t. Whereas the next part, whatever x will be there, we can simply distribute root t with that, and we can write in form of t raised to power something.
Yes, sir.
Yes, both of you have solved the second part of question 9.
So just last few steps are left.
Okay.
Yes, sir, done.
ओके, नैना हो गया क्या?
Yes, sir.
एक्सरसाइज 7.4 ओपन करना. ओपन किया एक्सरसाइज 7.4. एक बार चेक करो इस तरह के क्वेश्चंस तुम लोगों से बनते हैं क्या? फर्स्ट और सेकंड बनता है. क्या करना है इसमें, प्रोसेस बताऊं? एक एग्जांपल से हिंट ले लेते हैं, ठीक है? जैसे कि फॉर एग्जांपल आप ये चेक करो, पेज नंबर 381 का एग्जांपल 1 चेक करो. 381 का एग्जांपल 1 ओपन किया, पेज नंबर.
Yes, sir.
ओके, सो एग्जांपल में देखो क्या लिखा है, इंटीग्रेशन एक्स अंडर ब्रैकेट 5x² -7 होल रेस टू पावर 6. तो वो जो होल रेस टू पावर 6 वाला जो फंक्शन है ना, मतलब जो अंदर वाली टर्म है ना, उसको हम t सब्सटीट्यूट करेंगे. ठीक है. अच्छा, इसमें बुक में सब्सटीट्यूशन अप्रोच से नहीं बताया एक्चुअली, इसलिए तुम लोगों को ज्यादा इसमें समझ में नहीं आएगा एग्जांपल से. ओके, मैं ही एक आध दो एग्जांपल देके बता देता हूँ इसमें से. रैंडमली देखो यहाँ पर, जैसे मैं क्वेश्चन 7 ले रहा हूँ अभी एक्सरसाइज का. ठीक है, क्वेश्चन 7 का जो फर्स्ट पार्ट है, क्या लिखा हुआ है, इंटीग्रेशन x रेस टू पावर 5 अपॉन 1 प्लस एक्स टू द पावर 6 dx, ये लिखा हुआ है. तो देखो यहाँ पर क्या सब्सटीट्यूट करना है, यहाँ पर 1 प्लस एक्स रेस टू पावर 6, मतलब ये जो पूरा डिनोमिनेटर वाला पार्ट है ना, ये पूरा पार्ट, इस पूरे पार्ट को t ले लेना, ये पूरा पार्ट हो जाएगा t. डिफरेंशिएट करोगे तो 6x की पावर 5 आएगा डेरिवेटिव, दैट इज dt बाय dx. अब ये dx इधर जाएगा, 6 इधर, तो x की पावर 5 dx इज इक्वल्स टू क्या हो जाएगा, dt अपॉन 6. दिस इज हाउ वी विल रिप्लेस दिस टर्म विथ dt अपॉन 5. तो ये हो जाएगा dt अपॉन 5, और ये पूरा किससे रिप्लेस हो गया, t से. सो ये इंटीग्रेशन हो जाएगा, इंटीग्रेशन 1 अपॉन t इंटू dt अपॉन 5. Now we can take 1 upon 5 outside, 1 upon t dt, और इसका इंटीग्रेशन हम इजीली कर सकते हैं. तो इसमें सारे सब्सटीट्यूशन है, और ऐसे सब्सटीट्यूशन हम यूज करेंगे जिसका डेरिवेटिव हमको क्वेश्चन में दिया हो. ठीक है, जैसे कि फर्स्ट क्वेश्चन का फर्स्ट पार्ट नैना दिख रहा होगा तुमको शायद. ठीक है, एक्स क्यूब अंडर ब्रैकेट 1 प्लस एक्स रेस टू पावर
Yes,
4
sir.
होल क्यूब. सो इसमें किसको t सब्सटीट्यूट करेंगे नैना, बताओ?
1 plus x to the power 4.
करेक्ट. और फिर उसके बाद उसका डेरिवेटिव क्या आएगा?
3x.
नहीं,
Sorry, 4x cube.
4x क्यूब इज इक्वल टू dt बाई dx, लाइक दैट. ओके. चलो इसमें से चेक करो कौन से क्वेश्चंस मुझे बताने. जस्ट अ सेकंड. हाँ रेशम बोलो. एक सेकंड, एक सेकंड, एक सेकंड लाइन पे रहना. हाँ, क्या बोल रहे थे? हाँ, चले गए प्रिंटिंग के लिए. Yes. Huh. So any question from this exercise?
Sir, can we solve like from question number 6, 7, 8, especially these e to the power x and log related questions?
Yes, sure. We can start with questions like question 6, second part. We can start with that question, or any part you want me to tell to solve.
Sir, I think 4, 5, 6, 7, 8, all of them.
Hmm. 4, 5, 6. From 4 onwards.
Yes, sir. From
Okay,
fourth
so for
first.
question number 4, it is I is equals to integration e raised to power x under bracket a plus b e raised to power x whole raised to power 6 dx. Okay, so we will substitute this term as t. Okay, so that substitution part I'm writing here, a plus b e raised to power x is equal to t. Now differentiate, derivative will be b e raised to power x is equal to dt by dx. Okay, now
So
e
now
raised to,
can we solve further on our own?
yes. Look, your homework, for both of you, homework will be to solve all the questions or most of the questions from exercise 7.1 to 7.4. Okay, because if you practice more, then only we can proceed to higher level of questions, which is in 7.5 and 7.6.
Yes, sir.
Okay, so Naina, are you able to solve these questions?
Yes, sir.
Okay.
So then I'll practice such questions, especially these last ones.
Okay. So can we end with today's session, and we will discuss the doubts in next question from exercise 7.1 to 7.4. Okay.
Sir, when we will
Yes,
start
sir.
with sample paper?
Sample paper. Naina, which sample paper?
Sir, previous year questions.
Yes. Actually, I will take a printout of that previous year question, and whichever topic we were solving, we will take the questions from that exercise, from that sample paper. Okay. Like if you are solving integration, then whichever question is asked in previous year or in sample paper, we will consider those questions during this session. Okay.
Yes, sir.
Okay.
And so, like right now for maths, like you gave us homework for today, like apart from it, how exactly should we practice?
Uh, I think derivative we have already done the practice with
So
that.
should we like focus on one topic or we can try others also?
No, I think the better way to solve one topic right now, because if we have completed the syllabus 2 times, then only it is better to solve the sample paper directly. But as of now, we have completed only once, and if we because most of the formula and whatever things or approaches are there, we have already forgot, because it
Yeah,
was
I
in
get you.
backside memory in which we have studied first time. Okay, so it is better to revise that quickly, and after revising the complete syllabus one time, we will move to that sample paper solving question part. Okay.
Yes, sir. So right now we should focus on
Yes.
integration related questions
Yes,
only.
I think one more thing parallelly both of you can do is solving differentiation
Yeah.
problems based on differentiation, because we are directly starting with integration here. Differentiation we have already discussed with core batch. So try to solve differentiation from your book and ask me the questions, especially which are the important exercise. Let me tell you, both of you, that you have to keep in your mind, or you have to focus for that. Uh, that increasing decreasing problem is most important from your exam point of view, like which is in exercise, I think it is in exercise 6.4. That exercise 6.4, from question number 1 to question number 9, all the questions are important from increasing decreasing. Okay.
So like
uh
I was uh, previously I was solving this AOD
yes.
exercise first, but I was unable to solve the last few questions.
From this increasing, decreasing.
No, it's from rate of change.
Okay, rate of change. Actually, few questions are tricky. We will discuss the rate of change based question from previous year question and sample paper question. Okay, and
Yes, sir.
or any other doubt from your book, then we will consider those questions also. Okay. Also, one more thing, what you all can do parallelly is increasing, decreasing is quite simple topic. You can do, and
Yes, sir.
also we have discussed. So you can practice a few questions from derivative. The important exercises from 5.3. It is parametric form. Exercise 5.3. So solve this exercise. Okay, and also the exercise, I think it is 5.4. It is also important, especially the last few questions. Even all the questions from this exercise except the first question, 2, 3, 4, 5, 6, 7. All these questions are important. So
Yes,
5.4.
sir.
Okay. So these two exercise from derivative you can solve, and one exercise from AOD, that is increasing, decreasing. So during this period, try to solve these questions and send me your doubts if any. Okay.
Yes, sir.
Okay.
Okay, sir.
Okay, then we can end today's session. Thank you.
Thank you, sir.
Okay. Well.